course Project-Based Text Mining in Python. The data science jobs are on the rise, and considering the growth of data analytics for decision making, organizations are hiring more and more data engineers and experts these days. Textual data covers most of the data found in the organizations. The structured data that is stored in the relational databases is only a slim slice of the whole of data. While most of the data is unstructured, it's noisy, it's found in different formats, and it cannot be ignored from processing. In this course, we are going to study to understand the nature of textual data. We will discuss structuring the unstructured data into fixed length vectors so that it can be used for analysis with machine learning techniques. We will be covering data pre-processing to get rid of the unwanted characters, stop words, and other domain-specific unwanted tokens. This clean and unstructured data is provided to machine learning techniques for analysis. In specific, we will be covering document classification or categorization, document grouping or clustering based on their similarity, sentiment analysis or the subjective analysis of data, and information extraction, that is extracting useful information from within the data. The course also indicates towards building your own datasets by scraping data from the web and cleansing it. In the last module, 2 projects are built that comprises of most of the modules that were covered separately throughout the course. I'll be your instructor for the course, Dr. Taimur Khan. I have 8 years of experience in academia, and prior to that, I worked in software industry for 2 years. I did my PhD in computer science with major in computational linguistics. During my PhD, I worked with large-scale unlabeled data to extract useful information from it as a sequence of tasks. We built adaptive models that would share their knowledge across a sequence of tasks. Such models are called artificial general intelligence or lifelong machine learning. I did my master's from Swinburne University in information technology with major in web applications. I have published around 20 research articles, including both journal and conference publications, a book and a book chapter. I have also supervised final year projects almost in similar number related to the areas of computational linguistics, information extraction, recommender systems, natural language processing, sentiment analysis, and semantic web. The course is for students who are beginners to data science. They know how to program, particularly in Python, and have basic understanding of machine learning. Having said that, each concept is going to have a theoretical part that will help you understand the underlying concept and working mechanism, and then the second part, its implementation through the code, is demonstrated. If you have some know-how of natural language processing, that is good. We will be using it primarily for data pre-processing. Again, each concept covered from NLP will have a theoretical explanation and demonstration through the code. So anyone who is beginner to data science and have some concepts of programming can start with this course. Why in Python? Because Python is easy to work with, and I can assure you that. I wrote codes for my PhD models in Java, and they were a lot time consuming and difficult to debug. Recently, I have switched to Python, and it's a lot easier to work with. The code is more compact and has better readability. Most of the machine learning libraries and repositories are available in Python and can be easily imported into the code. Primarily, in this course, we will be working with scikit-learn and NLTK libraries throughout the course. The course is planned to have 8 modules. We will start with an introduction and a starter code that will give you a feel of how the course is going to be. In the second module, that is called Vectorizing the Data, we will structure the unstructured data and will convert data into vectors. This is also called converting data into a vector space model. Once data is converted into vectors, we are going to have columns as features, which will be words, and rows as documents. Each value in the matrix or the table is going to represent some numerical representation of a particular feature in a document. There are different schemes available for it, like frequency-based representation, binary representation, TF-IDF, etc. In the second row over here, that is representing machine learning, we will have three modules. There are classification or document categorization, grouping of documents or document clustering, and then validation and evaluation of these techniques. This will cover the machine learning part of the course. Validation is important because scientifically, when we perform analysis on a dataset, we need to split the data into training and test part using a mechanism that is trusted in the research community. And then once such a separation is being made, now we want to evaluate our models and compare them with different models. In practice, it will also be helpful to see which model is working better for a particular data given a task. Once the validation and the evaluation is being done, we will get back to the introduction and NLP, or the first row, and we will do pre-processing. Now, why we have delayed pre-processing up till this point is because pre-processing is an extra set of tasks that is going to improve on accuracy. So unless we have done some analysis and we have acquired some measure of accuracy, we would be able to see how much pre-processing is going to help on this measure. So that's why we are introducing preprocessor at the later stage to see if you have acquired some level of accuracy, if you pre-process the dataset, how that is going to affect the accuracy of that model. The next two modules are about the data analysis. We have topic modeling and sentiment analysis. Topic modeling is a technique used for information extraction from within the data, and in this module we are going to learn how topic model can be provided to any dataset, and we can acquire useful information as topics, which are groups of words belonging to that topic. Topic modeling is also considered as a dimensionality reduction technique because it takes data with a large number of features and convert them into few meaningful features, that is, topics. In the eighth module is about sentiment analysis. This module is about classification of documents, but not based on their similarity, but based on their sentiment or opinion similarity. Now, in this case, we are not going to consider all words for finding the similarity between documents. In fact, two documents are going to be identical in terms of sentiment analysis if they have similar sentiment orientation and strength. For example, if two documents are saying good things about the same product, so they are going to be classified as positive, while any document that is suggesting drawbacks in a particular product is going to be classified as negative sentiments. Sentiment analysis can be performed with two types of approaches. In case we are going with the dictionary-based approach, that is using WordNet or SentiWordNet, we are going to check the sentiment polarity and strength of each word and then combine them for a document to see if a document is positive or negative. We can also use the classification-based techniques that we studied in the earlier parts for sentiment analysis, where the labels are going to represent the sentiments of a document, for example, positive, negative, neutral, etc. In the final module, we are going to do two projects, and these projects are going to comprise most of the modules that we covered separately throughout the course, so that you can have a collective sense of how it's all going to work together. The objectives of this course are that you should be able to read data from a dataset or compile a dataset through web scraping. As we said, we'll also give you a hint how to scrape data from the web, cleanse it, and convert it into your dataset. You will learn how to pre-process the data, clean it, and structure it. You will learn how to identify machine learning models that would be helpful for a particular task given a dataset. In other words, you should be able to analyze a particular task and see which technique is going to work better. In fact, you can try multiple models, and then using the evaluation of these models, you can pick the best model. You will learn to perform information extraction from unlabeled data, and you should be also able to perform subjective analysis on the data, that is sentiment analysis. So, if you got any problems, suggestions, query, or comment, you can contact me directly through taimur.mohammed@gmail.com. You can also talk to me through the question answering portion of the portal, and I'm also happy to communicate with you through my Skype ID, that is TaimurKhan003. So register for the course and help me with your feedback to improve on the course. Thank you.